All right, here we go with the next group of problems. Question 8 says that we still want to rotate around x. So we're going to rotate around x. Wow, what's up with my tablet here? So what we're doing is spinning around the x-axis, but we're spinning and we're only interested in this from here to here. Those are the only places that we're interested in, okay? Which means that the shape that we really want to investigate is, whoops, let's get it to here, is this shape right here. And you'll notice if we revolve that around the x-axis, we're going to have some different radiuses, okay, or radii, or I don't know what the plural is for that. Maybe I need to teach geometry again, but I've got an inner radius right here. Okay, let's get that to a different color ink. I've got an inner radius right here. And then I've got an outer radius right here. And if I rotate this shape, these two lines around the x-axis, I'm going to get a volume of a piece that's hollowed out in the middle, almost like a donut, okay, or like a washer. And so in order to solve this problem, I'm going to use a washer setup, which means I'm going to integrate from our two points, A to B. And I still am dealing with circles because a washer is a circle. It's an outer radius and an inner radius. So I'm going to still have pi r squared, but this time I'm going to have pi times the big radius squared minus the little radius squared. Okay? So the big radius in this case goes up here to this blue line. That's the line negative x plus 6. When I integrate then, I'm going to start at some number I don't know yet, and I'm going to integrate with pi times the big radius squared, negative x plus 6 squared, okay? Minus the little radius, which is going to be the 5 divided by x. He's the smaller radius in here, so 5 over x squared. Here's my setup. The other thing that I have to do is I have to figure out, okay, at what point do these guys intersect? That's what I've got to find. So if you'll just set 5 over x equal to negative x plus 6, multiply both sides by x, move everything over to the left, and now you've got a quadratic function that you can factor. And when you factor this guy, you're going to find out that x factors to x minus 1, x minus 5. So x has to equal 1 and 5. And those are our limits of integration. Okay? This guy also is not too bad to work out by hand. If you're one of my students, you don't have to do that. But please pay attention to your teacher and honor their request. So I went ahead and punched this into my calculator, and I got 67.021. Or you could get 64 thirds pi. And remember, these are units cubed. Okay, so that's how these guys set up. On question 9, we're talking now about using a shell. Question 9 is using a shell method. And the shell method says that we're going to integrate from A to B, and we're going to do 2 times pi times height times radius. Okay, 2 times pi times height times radius. And with shells, it's a little bit different. So this particular shell is going to rotate around the y-axis. So it rotates this way. And if a shell rotates around the y-axis, we do all our integrating with x's. If a shell rotates around the x-axis, we do all our integrating with y's. So what we have to figure out then is the height of this guy. That is not too tricky. The height is just how far are we from the blue equation to the red equation. How far apart are those guys? And in this particular case, it's just the top equation minus the bottom equation. That will give you a height. So our top equation is 8 minus x squared. And our bottom equation is x squared. So our height is 8 minus 2x squared. Now, it's really tempting to cancel those out, but don't do that. You've got a negative x squared plus a negative x squared. The radius then is determined by how far you are from the x-axis. The radius is determined by how far you are from the x-axis, or the axis of rotation. So if I'm right here, I'm x units away. If I'm right here, I'm x units away. I'm x units away. And so it just depends on where you're at when you're looking for your axis of rotation. So what is your radius? It just depends on how far away you are from the y-axis. So for this problem, our radius is just going to equal x, okay? Because whatever value x is how big our radius is. So now we integrate this guy. And again, the integration part is not too tricky if you're doing by hand. My kids can use a calculator. By the way, we need to figure out where we're integrating from and to. Well, they told us that we're going to start at 0. We'll figure out this upper part in just a second. And I'm going to have 2 times pi times the height, which is 8 minus 2x squared, times the radius, which is x, times dx. We use this setup because we're rotating around the y-axis. We've got to figure out where these two guys intersect. And in order to do that, we just set the two equations equal. So I would have 8 minus x squared equals x squared. Add to x squared to both sides. Divide by 2. Take a square root. And remember, anytime you square root something, you get plus or minus. So here I've got plus or minus 2 equals x. The minus 2 is over here. I'm not worried about him. The plus 2 is the one that I'm really, really interested in. So integrate this guy. I went ahead and punched him into my calculator, and I got 50.265. The exact answer, if you need that as well, is 16 pi. So this also doesn't integrate. It's a pretty good integration. Units cubed for both of those because we're talking about a volume of a shell. All right, down here on the bottom, what we want to do is discover the length of these curves. Now, the directions on this sheet that I gave my students said to just set these up. Well, we're going to go ahead and set them up and solve them out because, hey, why not? All right. So the lengths of the curves mean that we're going to use a specific formula to integrate. And that formula looks like this. We're going to integrate from a to b, the square root of 1 plus the derivative squared. And in this case, let's go ahead and say y prime. And so that would be dx. Okay? Or you could integrate x prime squared dy. It just depends on which way we're going. Both of these happen to set up in a way that we're going to use derivatives of x. Okay? So the first guy says y cubed plus 3y is equal to 3x minus 1. Go ahead and add 1 to both sides. And divide everything by 3. So y cubed over 3 plus 1 plus 1/3 equals x. And when you find the derivative of that, x prime or dx dy, you're going to get y squared plus 1. So if I use this formula right here, I'm going to integrate from 1 to 2 on the y-axis. And I'm going to integrate the square root of 1 plus y squared plus 1 squared dy, because all my variables need to match. Go ahead and punch this one into your calculator because it's potentially really nasty if you don't. I'm just going to write the answer right here above number 10. And when I punch this in, I got 3.4895. And that's just units now because we're talking about a length. We're not talking about a volume or shape or anything. We're just talking about how long it took for us to travel from 1 to 2 along the curve. The other guy over here is x equals y sine y plus cosine y from 0 to pi. He also is set up pretty good for us. He's already set up. So to find x prime, we just have to use the product rule. You may or may not remember that, but it's the first times the derivative of the second plus the derivative of the first times the second. So the derivative of y is 1. And then the derivative of cosine y is minus sine y. I hope you can see that. The cool thing with this is plus sine y and minus sine y go away. So now when I integrate this guy, I'm going to integrate from 0 to pi, the square root of 1 plus y cosine y squared dy. And again, this is a pretty difficult problem to integrate without a calculator. So I went ahead and punched it in. And I got for the length of this curve 4.8478. And that's going to be units. So whatever units they give you to work with, that's your answer. We looked at a lot on this example. So with these 4 problems, from washers to shells to lengths of curves, you may need to pause, rewind, or whatever. Make sure you write down any questions you have, and let's talk about them.